Hi guys, welcome back to Think Tank. In this video I'm going to talk about changing the order of integration. Okay, so changing the order of integration is very helpful, especially when we are dealing with double integrals, triple integrals, finding volumes, finding areas. So we're given a problem here, and I have a couple of questions I'm going to work out here. So we're given a problem, and as you can see, we have to first integrate with respect to x, because x is our inner integral. And if we look at this function, it's x squared sine xy. Okay, so it's very hard to do integrate with respect to x. I don't know which method, either integration by parts or what, but it's very hard. But we can try to ease this problem by just changing the order of integration. So what is changing the order of integration? Okay, we want this problem to be dy dx, not dx dy. Okay, so all you have to do, the best way you can change the order of integration is by graphing. Okay, so if we were to graph these limits, okay, so this is dx, so that means these are the x limits. And what are x limits? So this is same as saying y is equals to 1, x equals y is equals to 0, x equals to 1, x equals to y, x squared sine xy dx dy. Okay, these are the y limits, same as y equals to 0, y equals to 1 and y equals to 0. So I am going to graph, and after graphing I want to find the region bounded by these lines. Okay, so I'm going to draw my xy plane here. So this is y and this is x. Okay, I'm going to start with this one. X equals to 1. Okay, that is easy. So this is a straight line, vertical line. X is equals to 1. Okay, so this coordinate is 1, and I'm going to x equals to y. Okay, so this is line gradient 1, so x is equals to y. Then what next? I'm going to y equals to 1. Y equals to 1 is a horizontal line. This is a horizontal line, and the coordinates of y is 1. This is equal to y equals to 1, and y equals to 0. So this is y equals to 0. Okay, and now as you can see, this is the region. This is the region I'm dealing with. And since I'm integrating with respect to x first, that's why I've drawn these horizontal lines. That means I'm coming from here to here. But what is my goal? My goal is to change the order of integration. I want to start from here to here. Okay, so if I want to change the order of integration in this problem, I want to first integrate with respect to y. So that means I will just find, so the x limit is going to be 0 and 1. Okay, because when I was integrating with respect to x, the y limits were from 1 to 0. Okay, so here just find the limits here, 0 to 1. Okay, these are the x limits. So I'm going to write here x is now from 0 to 1. And now I'm going to change the order. So that means my graph still the same. Okay, so x equals to y, and these are the x limit, x axis, y axis, y equals to 1, x equals to 1. This is 1. Now I want to change the order of integration from, I want to begin from here to here. Okay, so this means this is my y lower bound. Okay, this is my y lower bound, and as you can see, it's 0. Okay, 0. What about my upper bound? Okay, so my upper bound is this curve. Okay, so this curve is my upper bound. Okay, it's no longer 1, but it's this curve. Okay, as you can see. And what is this curve? This curve is x equals to y. Okay, so I'm going to write x here, and I'm going to copy this as it is x squared sine xy dy dx. Okay, then next I'm going to integrate the respect to y. Okay, so if we integrate the respect to y 1 0, I'm going to treat x as constant. So this is same as saying 2y or a number. X is a constant here, and here x is also a constant, so it's x squared, and the integral of sine x is negative cos, what was the value of the angle? Okay, so the value of the angle here is xy. Okay, so value of the angle is xy, and we're going to divide this by the derivative of the angle. So the derivative of the angle is x. Okay, just differentiate with respect to y, and if you differentiate this one, xy with respect to y is x. Okay, I'm going to put my limits here, x and 0 and dx. Okay, then I'm going to say lower bound minus upper bound, and if you do that, we're going to see that 1 0. Okay, so I'm going to replace y with x. Okay, so it's going to be x squared, this is the negative cos x squared over x, then cos 0. What is cos 0? Cos 0 is 1, because if I put y here, it's going to be 0. Okay, then cos 0 is 1 minus x squared. We have a negative here, negative 1 over x dx. 1 0 negative x squared. So if we divide x squared by x, we're going to see just negative x cos x squared. Negative and negative is now positive. X squared divided by x, positive x dx. So let me write it here. 1 0 negative x cos x squared plus x dx. Okay, and now I have to apply common sense here. So as you can see, you can't just integrate this. I'm going to use substitution, but I have two functions here, but x is easy to integrate. Okay, so I'm going to group them. 1 0 negative x cos x squared plus the integral of 1 0 x dx. Okay, I've forgotten dx here. Okay, so this is equal to 1 0 negative x cos x squared, and if we integrate x just going to add 1 to the power of x, then divide by the new power, so it's going to be plus x squared over 2 limits 1 0 dx here. 1 0 negative x cos x squared dx. Then I'm going to just say lower bound minus upper bound, and as you can see, this is going to be say x1, so that is going to be 1/2 minus 0, and that is 1/2. Okay, and now, so we want to choose our u substitution. I want to use our u substitution. So what I am going to do is that I am going to let me say u is equals to x squared, because I think this is the best substitution I'm going to use. U equals to x squared, so that means du dx is going to be 2x, and as you can see, if we make it dx below the formula here, dx goes to du over 2x. So that means this x is going to cancel this x. Okay, we're good. So come here, going to say negative x cos u. What about dx? We're going to put du over 2x 1 0, okay, plus 1/2. And now we're going to integrate. Okay, so this is negative, and if we integrate here, we're going to cancel this and this. So the integral of cos u just negatives, just cos u, the integral of cos u, it's sine, but we have a negative here, so it's negative sine u over 2. Our limits 1 0 plus 1/2 sine, and if we just say upper bound minus lower bound, we know that sine 0 is 1, sine 0 is 0, so that means this is going to be sine 1 over 2 plus 1/2, and if you evaluate that, you're going to get approximately 0.079, and this problem is done.